We want to reverse an array in place, turning 1, 2, 3, 4, 5 into 5, 4, 3, 2, 1. We will use recursion with 2 pointers, one starting at the left end and one at the right end. The idea is to swap the outer pair, then move both pointers inward and reverse the rest. Picture 2 fingers, one on the first element and one on the last. We swap what they point to, so the outermost pair is now in place. Then we move the left finger one step right and the right finger one step left, and reverse the smaller middle section the very same way. The pointers keep closing in until left meets or crosses right. That is the base case where everything is already reversed and we stop. Because the gap between the pointers shrinks by 2 every call, they are guaranteed to meet, so the recursion ends. If left has reached or passed right, the whole array is reversed, so we return it. That is the base case. Otherwise, we swap the elements at left and right in one line, then call the function again with left moved up by 1, right moved down by 1, reversing the inner part. Let's build it and watch a couple of arrays flip end to end. The base case. When the left pointer meets or passes the right, the array is fully reversed, so we return it. Swap the 2 ends in a single step, putting the outer pair in their reverse positions. Then recurse inward, moving left up and right down to reverse the middle. Now let's test it and hit run. There we go. 1 through 5 becomes 5 through 1. And 7, 8, 9 becomes 9, 8, 7. Each call swaps the ends and the pointers close in until they meet. The flow is clear. If left is at or past right, we return the array. Otherwise, we swap the 2 ends, then recurse with left increased and right decreased, closing in on the middle until the pointers meet. We do about half as many swaps as there are elements, so the time is order n. The space is order n because of the recursion stack, roughly n over 2 calls deep. An in-place loop with 2 pointers would do the same work in order 1 extra space. Remember these. First, the base case uses left greater than or equal to right, which correctly handles both even and odd lengths. Second, be sure to move both pointers each call, otherwise you swap the same pair endlessly. And third, for an odd length, the exact middle element never moves, and that is exactly right, since the middle element maps to itself when reversed.